Imagine holding a cup that changes color right before your eyes, one moment glowing a deep jade green, the next shimmering like blood-red wine. This isn't some modern invention or high-tech gadget. It's an ancient Roman artifact crafted over 1,600 years ago, and it holds secrets so advanced they defy everything we thought we knew about the past. The Lycurgus Cup isn't just a relic, it's a puzzle that has left scientists scratching their heads for decades. How could a civilization without microscopes or precision tools manipulate materials at the level of individual atoms? The answer lies in a phenomenon so rare, it feels almost like magic nanotechnology hidden in plain sight, centuries before the word even existed. Picture this, a lavish feast in 4th century Rome. The cup passes from hand to hand, dazzling guests as it catches the light, shifting hues like a living thing. To those who held it, the Lycurgus Cup was a symbol of wealth and power. But to us, it's something far more profound, a glimpse into a lost world of innovation that rivals our own. The cup's secret, tiny particles of gold and silver, ground so fine they're smaller than a grain of sand embedded in the glass. When light hits them, they scatter it in ways that alter the cup's color depending on the angle. It's a trick of physics so precise, modern engineers struggle to replicate it even with today's technology. How did the Romans achieve this? Were they accidental alchemists, or did they possess knowledge that history forgot? This isn't just a story about a beautiful artifact. It's a journey into one of history's greatest mysteries, a collision of art, science, and legend. The Lycurgus Cup is named after a tragic king from Greek mythology, forever trapped in the glass, entwined in vines as punishment for his defiance of the gods. But the real myth here isn't the legend etched into its surface. It's the idea that ancient craftsmen could master materials on a scale invisible to the naked eye. As we peel back the layers of time, we'll uncover the truth behind this staggering feat, the cutting-edge science hidden within ancient glass, the theories about how it was made, and why this tiny cup might rewrite what we thought possible in the ancient world. Ready to unravel the enigma, let's dive in. The Lycurgus Cup didn't emerge from the shadows of history with fanfare. It was quietly tucked away for centuries, waiting for the right moment to astonish the modern world. Discovered in the mid-1800s, likely in a Roman tomb or aristocratic villa, the cup's origins remain shrouded in mystery. What we do know is that it eventually found its way into the hands of collectors before being acquired by the British Museum in 1958. Where it now sits as one of the most enigmatic artifacts of the ancient world. At first glance, the cup seems unassuming, a delicate vessel standing just over 6 inches tall, adorned with intricate carvings depicting the myth of King Lycurgus ensnared by vines. But the moment light passes through it, the magic begins. In reflected light, the glass appears an opaque, earthy green, like moss clinging to stone. Yet when lit from behind, it transforms into a translucent, fiery red, as if filled with liquid garnet. This phenomenon, called dichroism, isn't just rare in ancient glass, it's practically unheard of. No other artifact from the Roman era or any civilization before the modern age displays such a dramatic and precise color shift. Experts were initially baffled. How could glass crafted over a millennium and a half ago behave like something out of a science fiction novel? The answer lay not in the artistry of the carving, but in the glass itself. Under magnification, scientists uncovered a breathtaking secret. The glass was laced with minuscule particles of gold and silver, each one just a few dozen nanometers wide, thousands of times smaller than a grain of salt. These nanoparticles, scattered through the glass like stars in a night sky, interact with light in a way that ancient artisans could never have fully understood, yet mastered with eerie precision. What's even more astonishing is that this wasn't a fluke. The cup's creators didn't stumble upon this effect by accident, they repeated it. Fragments of similar dichroic glass have been found elsewhere in the Roman world, suggesting a deliberate, if mysterious, technological tradition. The Lycurgus Cup isn't just a lone marvel, it's a whisper of an entire lost science, one that challenges our assumptions about what the ancient world was capable of. Standing in the British Museum today, it doesn't just tell a story of myth and craftsmanship, it dares us to rethink the boundaries of history itself. The scene carved into the Lycurgus Cup isn't just decorative, it's a window into a myth so potent. It was chosen to adorn one of antiquity's most extraordinary creations. King Lycurgus of Thrace, his body twisted in agony, forever trapped in a tangle of vines, represents a tale of hubris and divine retribution ripped straight from Greek mythology. According to legend, Lycurgus attacked Dionysius, the god of wine and revelry, and tried to destroy his sacred vines. For this sacrilege, the gods punished him by entwining him in the very plants he sought to obliterate, a living prison of leaves and tendrils that slowly drove him mad. The imagery is visceral, his face contorted in despair, his limbs swallowed by greenery, a stark warning against defying the natural order. But why immortalize this particular myth on a cup that seems to defy the laws of nature itself? The answer lies in the symbolism. Dionysius wasn't just a god of wine, he embodied transformation, the chaos of fermentation, the blurring of boundaries between mortal and divine. The cup's color-shifting properties mirror this theme perfectly, as if the glass itself is alive, shifting between states like the god's mercurial nature. The vines that ensnare Lycurgus aren't just punishment, they're a reminder of nature's power to reshape reality, much like the unseen forces at work in the cup's nanostructured glass. It's a metaphor rendered in artistry and science. Just as Lycurgus was undone by forces beyond his understanding, the cup's creators harnessed invisible forces to achieve the impossible. There's another layer here too. In Roman culture, drinking vessels weren't just tools, they were conversation pieces designed to provoke thought and display wealth. A cup that changed color while depicting a cautionary tale would have been the ultimate party trick, a reminder of mortality and divine wrath, even as guests indulged in wine. The Lycurgus Cup isn't just a feat of engineering, it's a narrative device blending myth and materialism in a way that still captivates us today. The choice of this myth suggests the cup's owners weren't just showing off their wealth, they were flaunting their connection to the divine, their understanding of secrets hidden in plain sight. The craftsmanship of the carving adds yet another dimension. Every vine, every fold of Lycurgus's robe is etched with precision so fine, it rivals the cup's nanotechnology. The artisans didn't just sculpt a scene, they created a dynamic tableau designed to play with light and shadow just as the glass plays with color. When wine filled the cup, the liquid would have cast rippling reflections across the carving, making the vines seem to writhe, a deliberate, theatrical effect meant to unsettle and awe. This wasn't just art, it was performance, a multisensory experience meant to humble anyone who held it. What emerges is a chilling irony, a cup celebrating Dionysius, a god of liberation, yet depicting a king imprisoned forever. Perhaps that's the real genius of the Lycurgus Cup. It's a paradox, an object of celebration that whispers of punishment, a masterpiece of control that relies on the uncontrollable dance of light and nanoparticles. The myth isn't just decoration, it's the key to understanding why this artifact was so revolutionary. In a world where science and superstition were inseparable, the cup bridges both, leaving us to wonder, did its makers truly grasp the forces they'd harnessed, or were they, like Lycurgus, caught in something larger than themselves? The Romans were master glassmakers, producing everything from delicate perfume bottles to towering window panes with techniques that would influence craftsmen for centuries. Their workshops hummed with activity, artisans blowing molten glass into molds or painstakingly cutting intricate designs into cooled surfaces. Most Roman glass followed predictable formulas, soda-lime-silica mixtures tinted with metal oxides, resulting in hues of blue, green, or amber. Even their most prized pieces, like the famed Portland vase, relied on layering colored glass rather than manipulating light itself. Then there's the Lycurgus Cup, a defiant outlier in this sea of tradition. What sets it apart isn't just the dichroic effect, but the microscopic engineering behind it. Ordinary Roman glass contained additives like iron or manganese to stabilize color, but the Lycurgus Cup's creators went further. They infused the glass with a precise ratio of gold and silver, around 1 part metal to 1,000 parts glass, then ground the metals into particles so small they'd be indistinguishable from dust to the naked eye. Modern analysis suggests these nanoparticles were likely created by dissolving the metals in glass, then reheating and cooling it in a process called striking, which causes the metals to precipitate into tiny clusters. The precision is staggering. A slight variation in temperature or timing would have rendered the effect inert. Even more perplexing is the absence of similar artifacts. While fragments of dichroic glass have surfaced, like those found at sites in Britain and Italy, none match the Lycurgus Cup's sophistication. A handful of Roman beads exhibit faint color shifts, but they lack the cup's dramatic red to green transition, suggesting they were crude experiments compared to this masterpiece. The cup stands alone, a technological Everest in a landscape of foothills. How did the Romans achieve this without electron microscopes or spectrometers? One theory points to accidental discovery. Perhaps a batch of glass contaminated with gold flecks, heated under unique conditions, revealed the effect by chance. But the cup's consistency hints at something more deliberate. Ancient texts like those by Pliny the Elder describe glassmakers adding metals like gold leaf to molten glass for luster, but none mention controlled nanoparticle synthesis. Could this knowledge have been a guarded secret, lost to time when Rome fell? Or was the cup an anomaly, the result of a lone artisan's genius that vanished with them? The contrast between the Lycurgus Cup and everyday Roman glass is like comparing a hand-cranked music box to a symphony orchestra. Both share the same fundamental materials, but one operates on a level so advanced it borders on alchemy. That's what makes this artifact so mesmerizing. It doesn't just defy expectations of ancient technology. It forces us to question the narrative of scientific progress itself. If the Romans could manipulate matter at the nanoscale, what else might they have known that history forgot? Hold the Lycurgus Cup up to the light, and something extraordinary happens. It doesn't just catch the light, it bends reality. In ordinary reflected light, the glass appears a dense, opaque green, like moss-covered stone or the deep shade of a forest at dusk. But tilt it slightly, let light pass through it instead of bouncing off its surface, and the transformation begins. The green melts away, replaced by a luminous, translucent red so vivid it looks like the cup is filled with wine or liquid ruby. This isn't a trick of the eyes or some clever paint. It's a property of the glass itself, a phenomenon modern science calls dichroism, where a material displays two entirely different colors depending on how light interacts with it. What makes this so baffling isn't just the effect, it's the precision required to achieve it. Today, we understand that the cup's color shift comes from nanoparticles of gold and silver embedded in the glass, each one roughly 1,000 times smaller than the width of a human hair. These particles scatter light in a very specific way. When light hits them from the front, they absorb shorter wavelengths like blue and green and reflect the rest, giving the cup its jade-like hue. But when light shines through the glass, those same nanoparticles interact differently, absorbing greens and yellows while letting reds dominate. It's a delicate dance of physics, one that depends on the exact size, shape, and distribution of those metal fragments. A variance of just a few nanometers would throw the whole effect off. So, how did Roman artisans working without microscopes, spectrometers, or even an understanding of atoms pull this off? One theory suggests accidental genius, Perhaps they added gold or silver flakes to molten glass as decoration, only to discover that under certain conditions, the metal broke down into microscopic particles, creating this stunning effect. But the Lycurgus Cup is too consistent, too deliberate to be a happy accident. Another possibility is that they developed a repeatable process, even if they didn't fully grasp the science behind it. Ancient texts mention gold-infused glass, and some even describe recipes for creating purple of Cassius, a colloidal gold solution used to tint glass and ceramics. Could this have been their gateway to nanotechnology? The real shock isn't just that the Romans achieved this effect, it's that they did it at all. Modern scientists didn't begin to understand how nanoparticles interact with light until the 19th century, and even today, replicating the cup's exact properties is a challenge. Laboratories can create dichroic glass, but matching the Lycurgus Cup's vivid, dynamic shift requires an almost alchemical precision. It's as if the cup's creators stumbled upon a secret that wouldn't be fully unlocked for another millennium and a half. And that raises an even bigger question. If they could manipulate materials at this scale, what else might they have known? The Lycurgus Cup isn't just a beautiful artifact, it's a relic of a lost science, one that hints at a lineage of knowledge we're still piecing together. Every time the cup changes color, it's not just light bending, it's history itself shifting under our gaze. When the Lycurgus Cup first came under scientific scrutiny, experts scrambled for explanations that fit within the known boundaries of ancient technology. One of the earliest theories suggested simple contamination. Perhaps traces of metal impurities had accidentally seeped into the glass during its creation, creating a fluke effect. After all, Roman glassmakers often recycled materials, melting down old vessels or adding metallic oxides for color. Could a stray fleck of gold or silver, unnoticed in the furnace, have triggered this optical marvel? The idea seemed plausible at first, but it quickly ran into a glaring problem. Randomness couldn't produce such a precise, repeatable phenomenon. Accidental impurities would result in uneven coloration, not the cup's flawless shift from green to red. Another hypothesis pointed to a lost technique, some forgotten alchemical recipe passed down through generations of glassmakers. Ancient texts, like the recipes recorded by Pliny the Elder, described elaborate methods for coloring glass using metals like copper or cobalt. Maybe the Romans had stumbled upon a way to harness gold's properties at an invisible scale, only for that knowledge to vanish amid the collapse of their empire. But this theory, too, hit a wall. No surviving manuscripts or archaeological evidence pointed to a deliberate process for creating dichroic glass. If it was a guarded secret, why were there no whispers of it in trade records or workshop notes? Then came the most tantalizing idea of all. What if the Romans had stumbled onto nanotechnology without realizing it? Some researchers proposed that artisans might have added gold leaf or powdered metal to molten glass as decoration, only to discover that under specific heating conditions, the metal fragmented into nanoparticles. Repeated trial and error could have refined the process, even if the craftsman didn't comprehend the atomic scale mechanics at work. But this raised its own questions. Without microscopes, how could they have consistently replicated particles of the exact size needed to scatter light so precisely? Modern labs struggle to control nanoparticle synthesis even with advanced equipment. The turning point came when scientists analyzed the cup's composition in the mid-20th century, revealing not just gold, but a meticulously balanced blend of gold and silver nanoparticles. This wasn't a haphazard mix, it was a recipe. The ratio of metals, their particle size, and their distribution through the glass were all calibrated to interact with light in this exact way. Accident or luck couldn't explain such intentionality. The Lycurgus Cup wasn't just a product of chance, it was the result of someone, somewhere in antiquity, unlocking a secret of material science that wouldn't be formally understood for centuries. What's striking is how these early theories, though flawed, reveal our own biases. we assume ancient people couldn't have manipulated matter at scales they couldn't see. Yet the cup forces us to confront an uncomfortable truth. Maybe they didn't need to understand nanoparticles to harness their power. Like a baker who masters sourdough without knowing about wild yeast, the cup's creators might have perfected their craft through observation and repetition, guided by results rather than theory. That's what makes the Lycurgus Cup so humbling. It doesn't just defy explanations, it exposes the limits of our imagination when it comes to the past. For centuries, the Lycurgus Cup was a dazzling mystery until the microscope finally caught up with it. In the mid-20th century, scientists wielding powerful electron microscopes zoomed in on fragments of the glass, peeling back layers of time at an atomic scale. What they discovered sent shockwaves through the archaeological world. The cup wasn't just tinted with gold and silver, it was engineered with them. Scattered throughout the glass like stars in a night sky were billions of metal nanoparticles, each one between 20 and 50 nanometers wide, smaller than a wavelength of visible light. These weren't random flecks, they were uniform, meticulously sized, and evenly distributed. The implications were staggering. The Romans had somehow manipulated matter at a scale invisible to the naked eye, achieving precision that shouldn't have been possible for another millennium. Here's where physics takes over. When light hits these nanoparticles, their tiny size triggers a phenomenon called surface plasmon resonance. Essentially, the electrons in the metal particles vibrate in sync with the light waves, absorbing specific colors and scattering others. Gold nanoparticles excel at absorbing green and blue light, allowing reds to dominate when light passes through the glass. But when light reflects off the surface, those same particles absorb red wavelengths instead, leaving the glass glowing jade green. It's not magic, it's nanoscale engineering so advanced modern scientists use similar principles in everything from medical imaging to solar panels. The cup's creators may not have known the physics, but they mastered the effect with eerie accuracy. What's even more remarkable is how they achieved this without modern tools. Today, creating nanoparticles requires precision instruments, high-energy lasers, chemical reactors, or vacuum chambers. The Romans had none of that. One theory suggests they used a rudimentary form of colloidal chemistry, dissolving gold and silver in molten glass before carefully cooling it to let the metals crystallize into nanoparticles. Ancient texts hint at recipes for purple of Cassius, a colloidal gold solution used to stain glass, which could have been their starting point. Another possibility involves grinding metals into ultrafine powders using mortars and pestles, then mixing them into the glass matrix through trial and error. Either way, they stumbled upon a process that modern science would later formalize as bottom-up nanoparticle synthesis, building structures atom by atom. Yet the Lycurgus Cup doesn't just showcase ancient ingenuity, it exposes the gaps in our historical narratives. For decades, scholars dismissed the idea that pre-industrial societies could manipulate materials at this scale. The cup forces us to reconsider. Maybe the Romans didn't just stumble upon this technology, maybe they refined it through generations of experimentation, passing down techniques orally or in lost manuscripts. Or perhaps the cup is a rare survivor of a broader tradition, one that vanished when Rome's glass workshops fell silent. Either way, its existence rewrites the timeline of scientific progress, proving that nanotechnology isn't solely a modern triumph, it's a rediscovery. And that raises a haunting question. If they could do this, what else did they know? The Lycurgus Cup isn't just a relic, it's a clue, a single thread in a tapestry of lost knowledge. Every time its colors shift, it's not just light bending. It's history itself pivoting, inviting us to look closer, to question deeper. Because sometimes the most revolutionary discoveries aren't found in the future. They're hidden in plain sight, waiting centuries for us to catch up. The secret behind the Lycurgus Cup's mesmerizing color shift lies in a dance of light and metal so small, it happens at a scale the human eye can't even see. Imagine throwing a pebble into a pond. The ripples spread outward in perfect circles, each wave interacting with the water around it. Now shrink that pebble down to the size of a single grain of sand and toss it into a pool the width of a human hair. That's essentially what's happening inside the cup's glass. The gold and silver nanoparticles embedded in it act like tiny pebbles, but instead of water, they're disturbing light itself, a phenomenon scientists call surface plasmon resonance. Here's how it works. When light hits these minuscule metal particles, their electrons start vibrating in unison, like a crowd doing the wave at a stadium. These synchronized vibrations absorb certain wavelengths of light while scattering others. Gold nanoparticles are particularly greedy for greens and blues, so when light passes through the glass from behind, they snatch those colors away, leaving only red to shine through. But when light bounces off the cup's surface instead, the particles absorb the reds, letting the greens dominate. It's as if the nanoparticles are microscopic bouncers at a nightclub, selectively filtering who gets in based on the direction they're coming from. To grasp just how precise this effect is, think of modern stained glass. A church window might glow ruby red because it's tinted with copper or gold oxide, but it'll stay the same color whether light shines through it or reflects off it. The Lycurgus Cup doesn't just filter light, it responds to it dynamically, like a hologram that changes depending on your angle of view. Today, we use similar principles in everything from biomedical sensors to anti-counterfeiting ink on currency. The difference, we rely on electron microscopes and spectrometers to achieve what Roman artisans accomplished with fire, intuition, and an uncanny knack for material alchemy. What's truly mind-bending is the scale of control involved. For the effect to work, the metal particles need to be between 20 and 50 nanometers wide, any larger or smaller, and the color shift collapses into muddled haze. That's like baking a cake where the sugar grains must all be exactly 1/5000th the size of a sesame seed, mixed evenly throughout the batter without clumping. Even with modern labs, hitting that sweet spot takes precision equipment. Yet somehow, with bellows and clay furnaces, the Romans cracked the code. Perhaps the closest modern parallel isn't stained glass, it's something far more futuristic: quantum dots. These nano-sized semiconductor particles, used in high-end TVs and solar cells, manipulate light in eerily similar ways. Like the cup's nanoparticles, their size dictates their color. But where quantum dots require synthetic chemistry and sterile labs, the Lycurgus Cup whispers of an older, cruder, yet no less brilliant path to the same destination. 2,000 years apart, separated by epochs of scientific revolution, both technologies converge on a truth the Romans glimpsed but never fully understood: that controlling matter at the smallest scales lets us harness light itself. This raises a humbling thought. We often frame history as a straight line from primitive to advanced, but the Lycurgus Cup scrambles that narrative. Its creators didn't just stumble upon nanotechnology, they weaponized it for art, embedding a secret in glass that would take humanity centuries to decode. Every time the cup shifts from green to red, it's not just showing us a trick of the light, it's revealing how much we still have to learn from the past. Consider the absurd difficulty of threading a needle without using your eyes. Now imagine threading one 1,000 times smaller, where even the slightest tremor would send the thread spiraling into nothingness. That's essentially what the artisans behind the Lycurgus Cup accomplished when they infused its glass with nanoparticles of near-perfect uniformity. Without microscopes, without atomic theory, without any conceivable way to observe what they were doing, they manipulated matter at a scale so minute, modern engineers would balk at the precision required. The statistical improbability of this feat is staggering. To create the cup's dichroic effect, the gold and silver particles couldn't just be small. They had to be consistently small, all falling within a tight range of 20 to 50 nanometers. For context, that's like demanding every grain of sand on a beach be the exact same width, down to a tolerance finer than a strand of DNA. even a slight deviation, particles clustering together or varying too much in size, would have turned the cup's vibrant color shift into a murky, muddled haze. Today, achieving this uniformity requires sterile labs, electron microscopes, and computer-controlled reactors. The Romans had clay crucibles and hunches. One theory suggests they might have relied on colloidal chemistry, dissolving gold in a liquid medium before mixing it into molten glass. Ancient texts describe methods for creating purple of Cassius, a colloidal gold solution used to tint glass, which could have served as a starting point. But here's the catch: even if they stumbled upon the right recipe, maintaining consistency across batches would have been like baking a perfect soufflé in a bonfire. Temperature fluctuations, impurities in materials, even the timing of cooling, any variable could have derailed the process. Yet the cup's nanoparticles are so evenly distributed, it hints at a controlled, repeatable technique, not luck. Compare this to modern nanotechnology, where scientists wield instruments like atomic force microscopes to nudge individual atoms into place. We've mapped the genome, split the atom, and yet replicating the Lycurgus Cup's exact properties remains a challenge. Laboratories can produce dichroic glass, but matching the cup's vivid, dynamic interplay of colors, where green and red aren't just present but transformational, requires an almost supernatural calibration of variables. It's as if the cup's creators possessed a cheat code to material science, one that bypassed centuries of trial and error, perhaps the most humbling thought. They likely never knew why it worked. Like a blacksmith tempering steel by the color of its glow, they might have perfected the technique through observation and repetition, guided by results rather than theory. The Lycurgus Cup doesn't just defy our assumptions about ancient technology, it exposes the arrogance of assuming progress is linear. Sometimes brilliance isn't about knowing the rules. It's about bending them blindfolded and hitting the bullseye anyway. The question of whether the Lycurgus Cup's nanotechnology was intentional or accidental isn't just academic, it's a puzzle that forces us to rethink the boundaries of ancient innovation. On one side of the debate, skeptics argue that such precision couldn't possibly have been deliberate without microscopes or an understanding of atomic theory. They point to the cup as a breathtaking fluke, a happy accident born from centuries of glassmaking trial and error. But the other side counters with a compelling detail: the cup isn't alone. Fragments of dichroic glass have been unearthed across the former Roman Empire, from Britain to Egypt, all sharing traces of metal nanoparticles. None match the Lycurgus Cup's brilliance, but their existence suggests a pattern. Not an isolated mistake, but a scattered tradition. Take, for example, the Roman cage cups, intricate glass vessels where the outer layer is carved away to leave delicate, lattice-like designs. These were feats of craftsmanship, demanding meticulous control over materials. Yet none exhibit the Lycurgus Cup's color shift. Then there are the rare dichroic beads found in Anglo-Saxon graves, faint echoes of the same effect, but murkier, less controlled. If the nanoparticles were purely accidental, why do these artifacts cluster in certain regions and time periods, as if following an unspoken recipe? The distribution hints at something more than chance, a guarded technique, perhaps passed orally between master glassmakers, lost when their workshops fell silent. Even more telling is the cup's composition. Modern analysis reveals the gold-to-silver ratio isn't random, it's calibrated. Too much silver and the red tones dull, too little and the green overwhelms. The artisans didn't just toss metal into molten glass and hope for the best. They tweaked the formula, iterating until the effect was undeniable. That's not luck, it's experimentation. And consider this: the cup's dichroism isn't a hidden feature. It's front and center, the star of the show. Would craftsmen invest such labor into a vessel without realizing its most dazzling trait? Unlikely, yet the debate persists because the alternative is so staggering. If intentional, the Lycurgus Cup implies a lineage of knowledge stretching back further than we've dared to imagine. Maybe its creators didn't grasp the physics of plasmon resonance, but they understood the outcome. Like chefs perfecting a recipe without knowing chemistry, they could have honed the technique through observation alone. The truth might lie somewhere in between, a mixture of accident and artistry where serendipity met relentless refinement. Every time the cup shifts from green to red, it's not just light bending. It's a challenge, daring us to reconsider what ancient hands could achieve when brilliance outran understanding. The Lycurgus Cup isn't the only relic that hints at forgotten mastery. History is littered with technologies so advanced for their time, they seem almost supernatural until they vanish without a trace. Take Greek fire, the Byzantine Empire's infamous weapon that could burn on water, its formula so fiercely guarded that it disappeared with the fall of Constantinople. Or Damascus steel, the nearly mythical blades that could slice through armor yet retain a razor's edge, their forging secrets lost when the last smiths took them to the grave. These weren't just feats of craftsmanship, they were black box technologies, processes so refined that their underlying science remained a mystery even to those who wielded them. The Lycurgus Cup fits snugly into this pantheon of lost arts, but with one chilling difference. Where Greek fire and Damascus steel were tools of war, the cup's nanotechnology served no practical purpose beyond sheer wonder. That raises a provocative question: why would such a painstaking technique be reserved for something as frivolous as a drinking vessel? The answer might lie in the Roman elite's obsession with status. In a world where power was displayed through spectacle, owning an object that defied explanation was the ultimate flex. The cup wasn't just functional, it was a conversation piece, a tangible demonstration of control over nature's most elusive forces. But if this technology was so prized, why didn't it spread? Why no treatises, no workshop records, no second act? The most likely explanation is also the most unsettling. The method was so fragile, so dependent on unwritten knowledge and tacit skill, that it couldn't survive the collapse of the institutions that nurtured it. Consider the fate of Roman glassmaking itself. After the empire's fall, the recipe for clear, durable soda-lime glass, once common across the Mediterranean, faded into obscurity for centuries. Medieval Europe reverted to crude, bubbly glass until Venetian artisans painstakingly reinvented the craft. If something as fundamental as transparent glass could be forgotten, imagine how easily a niche technique like nanoparticle infusion might vanish. The Lycurgus Cup's creators may have been part of a guild with closely guarded trade secrets, their methods passed down through apprenticeships rather than written manuals. When political chaos disrupted these networks, the knowledge evaporated like steam from a broken crucible. Yet there's another, darker possibility. Maybe the technology wasn't lost so much as abandoned. Nanoparticle-infused glass would have been exorbitantly expensive, requiring not just gold and silver but countless failed attempts to perfect the process. As Rome's economy crumbled, prioritizing luxury items over essentials became untenable. The cup might represent a dead end, a breathtaking one, but still a casualty of shifting priorities. That's the tragedy of lost technologies. They don't always disappear in flames or fall victim to barbarian hordes. Sometimes they simply fade away, victims of neglect, their brilliance too fragile to outlast the societies that birthed them. What makes the Lycurgus Cup so haunting isn't just the gap in our knowledge, it's the realization that history isn't a steady march forward. Progress stumbles, backtracks, and leaves pockets of genius buried in its wake. The cup's dichroic magic is a flare from the past, illuminating not just what the Romans achieved, but how much we've yet to rediscover. Today's scientists, armed with electron microscopes and atomic-level modeling, have tried to reverse engineer the Lycurgus Cup's magic, only to discover that ancient craftsmanship is harder to replicate than anyone imagined. In the 1990s, researchers at the British Museum teamed up with materials scientists to recreate the cup's dichroic effect from scratch. They started with the basics, melting silica sand with soda ash and lime, just as Roman glassmakers would have. Then came the tricky part, infusing the molten glass with gold and silver nanoparticles. Even with precision instruments, their first attempts failed spectacularly. The particles either clumped together, turning the glass murky brown, or dispersed unevenly, resulting in a weak, splotchy color shift. It took dozens of iterations to realize that the Romans hadn't just added metals to the mix. They'd perfected a specific heating and cooling cycle, a rhythmic dance of temperature changes that coaxed the nanoparticles into their ideal size and distribution. One breakthrough came when modern experimenters turned to colloidal chemistry, suspending gold particles in a liquid solution before mixing them into the glass. This mimicked the ancient purple of Cassius technique, but even then, controlling the nanoparticle size was maddeningly difficult. Too hot, and the particles would fuse into useless clusters. Too cool, and they'd fail to form at all. The team eventually succeeded in producing dichroic glass, but their version lacked the vivid, dynamic contrast of the original. The Lycurgus Cup doesn't just switch between green and red, it does so with a theatrical flourish, as if the glass itself is alive. Modern replicas, by comparison, often feel muted, like a faded photocopy of a masterpiece. Part of the problem lies in the raw materials. Ancient glassmakers used gold and silver mined from specific sources, often containing trace impurities that subtly altered their behavior. Today's ultra-pure metals lack these flaws, which might have played an unexpected role in the process. Then there's the human factor. Roman artisans relied on intuition, judging temperatures by the color of the molten glass and the sound of the furnace, a skill honed through generations of trial and error. No algorithm can replicate that tactile wisdom. Perhaps the most humbling lesson came from an unexpected source, a glassblower in rural France who abandoned high-tech methods in favor of ancient tools. Working with a wood-fired kiln and handmade crucibles, he stumbled upon a startling discovery. By adding crushed gold leaf to the glass at the exact moment, the furnace reached a cherry-red glow. Then rapidly cooling the mixture in a barrel of water, he produced a rough but unmistakable dichroic effect. His results were inconsistent, but they hinted at a truth modern labs had overlooked. The Romans might have harnessed the unpredictability of their materials rather than fighting against it. The gap between ancient and modern attempts reveals something profound. The Lycurgus Cup wasn't just a product of technique. It was a marriage of art and accident where mastery met serendipity. Today's scientists can explain the physics behind it, but recreating the cup's brilliance still eludes them. It's as if the original artisans left a final, unspoken ingredient out of the recipe, one that can't be found in a lab, only in the lost whispers of a Roman workshop. Every failed replication isn't just a setback. It's a tribute to the quiet genius of hands that worked without blueprints, transforming raw materials into a legacy that still dazzles the world. Imagine a dimly lit chamber filled with incense smoke, where robed figures pass the Lycurgus Cup from hand to hand, its surface pulsing between emerald and crimson as torchlight flickers around it. This wasn't just a party trick, it was theater, a calculated spectacle designed to blur the line between the earthly and the divine. The cup's color-shifting properties would have been catnip for Dionysian cults, secretive groups that worshipped the god of wine, ecstasy, and transformation. In their rituals, intoxication wasn't just revelry, it was a sacrament, a way to channel Dionysus's power to dissolve boundaries. A vessel that physically embodied this metamorphosis, shifting from the green of fertile vines to the red of spilt wine, would have been the ultimate ritual object, a tangible manifestation of the god's presence among the faithful. But the cup's allure wasn't confined to shadowy ceremonies. In the lavish symposiums of Rome's elite, where philosophers debated and poets recited, the Lycurgus Cup would have been a centerpiece, literally. Hosts would have staged dramatic reveals, filling it with wine so the liquid seemed to ignite from within as light passed through. The effect wasn't just decorative, it was psychological. Romans believed wine carried Dionysius's essence, and a cup that appeared to bleed red when filled with it reinforced the idea that the divine lurked in every sip. Guests might have interpreted the color shift as a sign of the god's favor, or a warning against excess, echoing the myth of Lycurgus himself, destroyed by his defiance of Dionysus. The craftsmanship hints at deeper symbolism. The cup's dichroism isn't instantaneous. It unfolds gradually as light shifts, mirroring the slow unraveling of inhibitions during a Dionysian rite. And consider its size, just over 6 inches tall, designed to be cradled in 2 hands, forcing drinkers to engage intimately with its magic. This wasn't a vessel for chugging. It demanded reverence, a pause to witness the transformation. Some scholars speculate it might have been used in initiation rituals, where the color change symbolized the initiate's own spiritual metamorphosis, passing from the green naivety of the uninitiated to the red enlightenment of the devotee. Yet there's a darker possibility. The cup's imagery, Lycurgus ensnared by vines, served as a visceral reminder of the god's wrath. In a religious context, it could have functioned as a memento mori, a warning that even kings who crossed Dionysus faced entanglement and ruin. Picture a priest filling the cup during a ceremony, the wine dark red evoking blood, the green vines turning to serpents in the flickering light. The message was clear: submit to the god's ecstasy or be consumed by it. What's chilling is how seamlessly the cup bridges sacred and profane. In a symposium, it dazzled as a status symbol. In a temple, it terrified as a conduit of divine power. This duality might explain why no written records explicitly describe its use. Those who understood its significance guarded the knowledge closely, just as Dionysian cults guarded their mysteries. The Lycurgus Cup wasn't just a drinking vessel, it was a psychological weapon wielded to awe, convert, and control. Every color shift was a performance, a carefully staged miracle reminding all who held it that some secrets weren't meant to be spilled, only sipped slowly in the dim glow of torchlight. The Lycurgus Cup stands as an ancient marvel, but it's far from the only artifact where early civilizations displayed an uncanny grasp of material science at microscopic scales. Take Damascus steel, the legendary blades wielded by warriors from the Middle East to medieval Europe. Under modern microscopes, these swords revealed a microstructure of carbon nanotubes and nanowires, a lattice so finely engineered, it gave the blades their signature flexibility and razor-sharp edge. Yet unlike the cup, Damascus steel's secrets were rooted in raw material alchemy. The steel's unique properties came from trace impurities in Indian Wootz iron ore, a lucky geologic quirk rather than deliberate nanoengineering. Once the ore mines were exhausted, the knowledge vanished. Then there's Mayan blue, a pigment so chemically stable, it still clings to temple walls centuries later. Scientists discovered its durability stems from indigo molecules trapped inside palygorskite clay, a natural nanocage shielding the dye from moisture and decay. But again, this was likely a happy accident of mineral chemistry, not an intentional nanostructure. Even China's Han Dynasty mirrors, which project cryptic patterns when light reflects off their corroded surfaces, owe their magic to bronze alloys that decay into nanostructured patinas over time. What sets the Lycurgus Cup apart is the sheer intentionality behind its design. Those other artifacts achieved their properties through material quirks or environmental wear. The cup's creators didn't just stumble upon dichroic glass, they weaponized it. They calibrated gold to silver ratios, controlled particle sizes down to nanometers, and repeated the process across multiple artifacts. This wasn't alchemy, it was proto-science, a systematic exploration of how matter behaves at scales no Roman could see. While Damascus steel and Mayan blue impress us with their side effects, the Lycurgus Cup dazzles with its purpose. Perhaps the most telling contrast lies in legacy. The recipes for Damascus steel and Mayan blue were lost because their creators didn't fully understand why they worked. The cup's makers may not have known plasmon resonance, but they clearly grasped cause and effect. Adjust the metal, tweak the heat, and the glass responds. That's why, centuries later, we're not just analyzing the Lycurgus Cup, we're still trying and often failing to reproduce it. Other ancient nano-artifacts whisper of accidental genius. This cup, it speaks the language of mastery. Centuries after the fall of Rome, glassmakers across Europe struggled to replicate even the most basic transparency of Roman glass, let alone the Lycurgus Cup's color-shifting wizardry. Medieval artisans working in the shadow of collapsed empires produced glass that was thick, bubbly, and tinged with greens or browns from iron impurities, functional at best, crude at worst. By the Renaissance, Venice's famed Murano glassmakers had revived the art of delicate, colorless glass, creating masterpieces that rivaled Roman clarity. Yet even their most dazzling creations couldn't touch the cup's nano-engineered brilliance. The irony is palpable. An era that birthed the telescope and the microscope, that mapped the stars and dissected the human body, still couldn't crack the code of this ancient drinking vessel. Take the stained glass of Gothic cathedrals, for example. These towering windows transformed sunlight into divine narratives, their vibrant pigments painstakingly crafted from metal oxides, cobalt for blue, copper for red, silver for gold. But the colors were static, locked into place by chemistry. No matter how the light shifted outside, the glass remained stubbornly unchanged. Compare that to the Lycurgus Cup, where every tilt of the wrist revealed a new hue, as if the glass held a secret dialogue with the light itself. Renaissance glassmakers could mimic the cup's green or red tones separately, but the dynamic interplay between them, that remained as mysterious as ever. Even the celebrated Venetian cristallo, the crown jewel of Renaissance glass, reveals the gap. Named for its resemblance to crystal, this ultra-clear glass was a marvel of its time, so prized that Venice enforced draconian laws to prevent its artisans from sharing the recipe. Yet for all its purity, cristallo lacked the cup's hidden dimensions. It was a blank slate, a canvas for decoration rather than a participant in the spectacle. The Lycurgus Cup didn't just hold wine, it performed with it, its colors shifting as liquid filled or emptied, a feature no Renaissance goblet could hope to replicate. The deeper you dig, the stranger the disconnect becomes. By the 17th century, scientists like Isaac Newton were unraveling the physics of light, proving with prisms that white light contained multitudes. Glassmakers had access to grinding techniques precise enough to craft lenses for telescopes and microscopes. And yet, the idea of embedding metal particles to manipulate light at the nanoscale remained beyond their grasp. It's as if the cup existed in a parallel timeline, one where Roman artisans glimpsed a future that wouldn't fully arrive until the quantum age. What's most telling is how later cultures interpreted the cup when they encountered it. Medieval scholars steeped in alchemy might have dismissed its dichroism as mere magic, a trick of the devil or a relic of pagan sorcery. Renaissance humanists obsessed with rediscovering antiquity would have marveled at its craftsmanship but missed its scientific significance entirely. Even as Europe marched toward the Enlightenment, the cup's true genius lay dormant, waiting for a century that could finally see the invisible. This isn't just a story of technological regression. It's a testament to how knowledge can fracture, how a technique honed over generations can vanish when the threads of tradition snap. The Lycurgus Cup didn't just outshine medieval and Renaissance glass, it haunted it, a ghost of lost potential whispering from the past. Every failed attempt to replicate it, every puzzled glance from a guild master or natural philosopher, only underscored the unsettling truth: some secrets aren't just forgotten. They're hiding in plain sight, daring us to catch up. Today, the Lycurgus Cup sits in a carefully controlled display case at the British Museum, shielded from the very forces that make it so dazzling: light and time. The museum's conservation team faces a paradox. How do you study an object that could literally disintegrate under scrutiny? the cup's nanoparticles, so precisely engineered by ancient hands, are now its greatest vulnerability. Over centuries, environmental exposure has caused microscopic deterioration in the glass matrix, threatening to destabilize the metal particles that create its iconic color shift. Even ambient humidity or minor temperature fluctuations could accelerate this decay, turning the cup's vibrant hues into a cloudy haze. Modern preservation relies on a delicate balancing act. The cup rests in a sealed environment with humidity locked at 45% and temperature maintained at a steady 19 degrees Celsius, conditions precise enough to make a sommelier blush. Lighting is another minefield. To showcase the dichroic effect without risking damage, conservators use fiber optic lamps with ultra-low UV emissions, positioned to minimize exposure while still allowing visitors to witness the green-to-red transformation. It's a far cry from the torchlit feasts where the cup once dazzled Roman elites, but necessary to ensure it survives for another millennium. The ethical dilemma cuts deeper than climate control. Every scientific examination, no matter how gentle, carries risk. Taking samples for analysis could disturb the fragile nanoparticle distribution, while advanced imaging techniques like X-ray fluorescence still expose the glass to trace radiation. Some researchers argue that the cup should be locked away entirely, studied only through non-invasive scans and historical records. Others counter that without physical analysis, we might never unravel its full secrets, knowledge that could rewrite chapters of material science history. The British Museum has chosen a middle path, limiting direct handling but allowing carefully monitored studies that prioritize the artifact's longevity. Adding to the complexity is the question of restoration. Should conservators attempt to stabilize the nanoparticles with modern coatings, knowing that any intervention could irreversibly alter the cup's chemistry? Or is it better to let nature take its course, preserving the object's authenticity even as its brilliance fades? For now, the museum errs on the side of minimal interference, treating the Lycurgus Cup not just as an artifact, but as a living document of ancient ingenuity, one whose final chapters were not yet ready to close. This isn't just about protecting glass and metal. It's about safeguarding a whisper from the past that still challenges our understanding of history. Every time the cup shifts color under museum lights, it's not just performing for visitors, it's testing the limits of our ability to preserve the impossible. The conservators' greatest fear isn't that the cup will crumble tomorrow, but that future generations might inherit a version robbed of its magic, leaving them to wonder if the legends were ever true at all. The Lycurgus Cup has seeped into modern pop culture like a whispered secret, sparking wild theories and fictional reinterpretations that blur the line between history and myth. Documentaries like Netflix's Mysteries of the Unexplained and the BBC's Secrets of the Ancients have dedicated entire segments to the cup, framing it as proof of ancient high-tech, an artifact so advanced it shouldn't exist. These shows often pair its shifting colors with dramatic music and slow-motion close-ups, turning the cup into a protagonist in its own sci-fi thriller. Even mainstream science series, usually reserved for black holes and quantum physics, can't resist its allure. Nova once featured it in an episode titled Decoding the Past, where materials scientists debated whether the Romans had stumbled upon nanotechnology or inherited it from an even older, lost civilization. Then there are the fringe theories where speculation runs rampant. Ancient astronaut enthusiasts point to the cup's dichroic effect as evidence of extraterrestrial influence, arguing that no pre-industrial society could have achieved such precision without otherworldly guidance. Some claim the nanoparticles are remnants of alien, smart materials, while others suggest the cup was a ceremonial object for communicating with interdimensional beings. More grounded but no less sensational theories propose it was a relic from Atlantis or a surviving fragment of the library of Alexandria's secret experiments. These ideas might lack academic backing, but they thrive in forums and YouTube videos where the line between archaeology and fan fiction dissolves into clickable intrigue. The cup's mystique has even inspired fiction. In the novel The Archimedes Codex, a thriller about rediscovered Greek technology, a Lycurgus-like artifact becomes the key to unlocking an ancient superweapon. Video games like Assassin's Creed and Tomb Raider have featured similar objects as plot devices, often tying them to secret societies or lost civilizations. Even comic books have taken swings. Marvel's SHIELD series once hinted that the cup was forged by a clandestine order of Roman scientists who dabbled in proto-quantum physics. What's fascinating isn't just the wild theories themselves, it's why they persist. The cup taps into a universal itch for the unexplained, a longing for history to be stranger and grander than textbooks admit. Unlike straightforward artifacts like swords or pottery, it defies easy categorization. Is it art, a scientific breakthrough, a religious object? That ambiguity makes it a blank canvas for speculation. Every time a documentary dramatizes its unsolved mystery or a novelist spins it into fantasy, the cup's legend grows, its true origins overshadowed by the stories we project onto it. Yet beneath the sensationalism lies a quieter truth. The cup doesn't need aliens or Atlanteans to be extraordinary. Its real magic is human proof that curiosity and craftsmanship could achieve the impossible long before we had the words to explain how. Pop culture might dress it in conspiracy, but the facts are dazzling enough. After all, when reality includes a 2,000-year-old nanotech marvel, who needs fiction? The same shimmering nanoparticles that dazzled Roman aristocrats now pulse at the heart of modern medicine, tucked into devices so small they navigate our bloodstreams. Scientists studying the Lycurgus Cup realized something revolutionary. Its gold nanoparticles don't just bend light, they react to their environment. Today, that insight fuels breakthroughs like cancer detection sensors, where nanoparticles coated with antibodies glow when they encounter tumor cells, acting as microscopic alarms. Researchers at MIT have even developed smart surgical sutures laced with gold nanoparticles that change color when infections arise, giving surgeons real-time warnings, a direct descendant of the cup's ancient light-bending trick. These applications go beyond medicine. Architects now harness dichroic glass inspired by the cup's properties to design buildings that adapt to sunlight. The windows of Dubai's Burj Khalifa, for example, use nanoparticle coatings to regulate heat and glare, shifting transparency like the Lycurgus Cup on a colossal scale. Meanwhile, engineers at Stanford have created ultra-thin solar panels embedded with gold nanoparticles that trap sunlight more efficiently, mimicking the way the cup's particles capture and scatter specific wavelengths. Perhaps the most poetic twist lies in anti-counterfeiting technology. High-security banknotes and passports employ nanoparticle inks that shift colors under different angles, a feature indistinguishable from the cup's behavior. The very innovation that once signaled elite status in Rome now safeguards modern economies. Even your smartphone might owe a debt to this ancient artifact. Some touchscreen coatings use nanoparticle layers to reduce glare, a subtle nod to 2,000-year-old craftsmanship. What's remarkable isn't just that the cup's technology has been replicated, it's how its principles have been expanded. Where Roman artisans worked blindly with nanoparticles, modern scientists manipulate them with atomic precision, arranging them into nanoantennas that control light for quantum computing or crafting plasmonic metamaterials that bend light around objects. The Lycurgus Cup was a solitary masterpiece, but its legacy is a sprawling revolution, proving that the seeds of tomorrow's science often lie buried in yesterday's wonders. Every time a surgeon spots an infection through glowing sutures or a skyscraper cools itself with smart glass, the ghost of an unnamed Roman glassmaker whispers across the centuries, their accidental genius now the bedrock of a nano-enabled future. The most baffling mystery of the Lycurgus Cup isn't how it works, it's why this revolutionary technology seemingly vanished without a trace. If Roman artisans truly mastered nanoparticle engineering, why do we find no evidence of it spreading across their vast empire? One theory points to economics. Gold-infused glass would have been staggeringly expensive, limiting its use to a handful of elite commissions. But that doesn't explain why even fragments of similar dichroic glass are vanishingly rare. Compare this to Roman concrete, another advanced technology that proliferated across aqueducts and colosseums. Concrete was practical, glass like this was pure spectacle. Perhaps when Rome's economy crumbled, priorities shifted from luxury to survival, and the secret faded with the craftsmen who held it. Another possibility is more unsettling. What if the cup represents not a lost tradition, but a dead end? History is littered with one-off innovations, like Archimedes' legendary heat ray or Heron of Alexandria's steam engine, that were too far ahead of their time to take root. The Lycurgus Cup might have been the work of a single visionary workshop, their techniques never documented because they were seen as trade secrets rather than scientific breakthroughs. Without apprenticeship systems to pass the knowledge forward, the method could have died with its creators. Then there's the tantalizing question of what else might be out there. Museums worldwide house countless unstudied Roman artifacts. Could some conceal similar nano-secrets? In 2019, researchers using advanced imaging on a collection of ancient Egyptian beads discovered unexpected gold nanoparticles, hinting at earlier experimentation with light-altering materials. And what about the legendary Alexandrian glass mentioned in medieval texts, said to rival the clarity of crystal? Could those lost recipes have included nanoparticle techniques we've yet to rediscover? The challenge is that identifying such properties requires destructive testing or cutting-edge scanners, leaving many artifacts unexamined for fear of damage. The silence of historical records deepens the puzzle. Roman writers like Pliny boasted about glassmaking innovations, yet none mention this color-shifting marvel. Was it deliberately omitted, its methods reserved for initiates of Dionysian cults or imperial workshops? Or does its absence suggest the cup was so anomalous that contemporaries didn't know how to categorize it? What lingers is the uneasy realization that history isn't a steady march of progress. It's a patchwork of brilliance and oblivion. The Lycurgus Cup forces us to confront how much ancient knowledge might have slipped through the cracks, not in grand collapses, but in quiet moments when a master artisan died without an heir or a recipe was misplaced. Every unanswered question about this artifact is a door left ajar, inviting us to wonder what other marvels might be hiding in plain sight, waiting for the right light, the right angle to reveal their secrets. To truly grasp the magic of the Lycurgus Cup, picture this: a split-screen demonstration where one side shows the cup under direct light, glowing that deep forest green, while the other side reveals the same cup backlit, transformed into a vessel of liquid fire. Now imagine stepping into that dimly lit Roman dining room, torchlight flickering as a servant fills the cup with wine. As the liquid rises, the glass doesn't just hold the wine, it becomes part of the performance, shifting from opaque green to translucent red as if reacting to the pour. You're not just seeing a color change, you're witnessing physics and artistry colliding in real time. For those craving a deeper dive, modern 3D animations could peel back the layers of the cup's structure, zooming in until gold and silver nanoparticles swarm like constellations in the glass. Watch as light particles, photons, collide with these microscopic metal flecks, bending and scattering in precise ways that our eyes interpret as color. One animation might freeze the moment a photon strikes a nanoparticle, showing how the angle of impact dictates whether green or red dominates. Another could illustrate how the Romans might have heated and cooled the glass, with particles forming like crystals in molten syrup, locking the secret into place. But here's where imagination kicks in. Close your eyes and picture holding the cup yourself. Your fingers trace the carved vines ensnaring Lycurgus as you tilt it toward a candle. The warmth of the flame dances through the glass, and suddenly, the king's torment isn't just a static scene. It's alive, the vines seeming to writhe as shadows shift with the changing hues. This isn't a museum exhibit behind glass. It's a kinetic masterpiece responding to every flicker of light, every drop of wine, every subtle movement of your hand. That intimacy, the way the cup invites you to participate in its illusion, is what elevates it from artifact to experience. Now consider this: what if we could recreate that moment today? Scientists have attempted replicas, but none capture the full drama of the original. Side by side, a modern imitation might shift from murky brown to dull purple, while the Lycurgus Cup erupts in chromatic fireworks. The difference isn't just technical, it's theatrical. The Romans didn't just engineer nanoparticles, they staged a spectacle, turning physics into poetry. Every tilt, every pour, every shift of light was choreographed to awe. That's the real magic no animation can fully capture. The weight of history in your hands, whispering across centuries that some wonders weren't meant to be analyzed. They were meant to be felt. The question of who crafted the Lycurgus Cup, a lone visionary or a secretive collective, opens a window into the shadowy world of ancient expertise, where knowledge was power and power was closely guarded. Picture a master glassmaker, fingers scarred from decades at the furnace, stumbling upon the nanoparticle effect by accident during a late-night experiment. Maybe they'd added gold leaf to molten glass as a decorative flourish, only to pull a cooling fragment from the ashes and gasp as it shifted from green to red in the firelight. Such a discovery would have been revolutionary enough to hoard like a dragon's treasure, passed down only to a chosen apprentice on the artisan's deathbed. The cup's singularity supports this romantic theory, its unmatched precision suggesting the touch of one extraordinary mind rather than a committee of hands. Yet the guild hypothesis is equally compelling. Rome's glass workshops were hubs of trade secrecy, where techniques like cameo glass cutting and millefiori required coordinated specialization. The few surviving fragments of dichroic glass found across the empire hint at a shared, if rare, tradition rather than a fluke. Perhaps the cup was the magnum opus of a Dionysian cult's inner circle, its creation ritualized in torchlit underground chambers. Glassmaking in antiquity wasn't a solitary art. It required teams to gather sand and soda ash, tend blistering furnaces, and blow molds while the glass remained pliable. Infusing nanoparticles consistently would have demanded even more collaboration. One artisan to mix metals, another to monitor temperatures, a third to anneal the glass at precise intervals. Like medieval cathedral builders who encoded their techniques in guild symbols, these craftsmen might have concealed their methods behind layers of ritual and apprenticeship. The social implications of either scenario are staggering. If a single genius engineered the cup, their identity was erased by history. No signed boast like the artist's signatures on Greek vases, no tomb inscriptions celebrating their mastery. This absence speaks volumes about how Rome valued artisans, as nameless conduits of luxury rather than celebrated innovators. But if a guild orchestrated the feat, their silence is even more telling. Unlike military technologies or architectural innovations, which emperors trumpeted as propaganda, the cup's magic served no practical utility beyond awe. Its creators may have been ordered to secrecy, their knowledge deemed too destabilizing if it fell into rival hands. Imagine the chaos if every provincial governor could commission dichroic glass. Roman elites thrived on exclusivity. What's chilling is how thoroughly the cup's origins were scrubbed from record. Even Pliny the Elder, whose natural history catalogued everything from glow in the dark shellfish to asbestos cloth, never mentioned color-shifting glass. This wasn't an oversight, it was censorship. Advanced material science in the wrong hands could undermine the social order. The same empire that standardized concrete for public aqueducts kept the ingredients for Damascus steel a state secret. Knowledge, especially that which bordered on the mystical, was privilege incarnate. The Lycurgus Cup thus becomes more than an artifact. It's a litmus test for how antiquity treated breakthrough innovation. Today, we patent discoveries and publish papers. Rome's answer was to bury them in unmarked graves or the palaces of emperors. Every swirl of green and red in its glass isn't just light bending. It's the ghost of a system where brilliance was either vanished or weaponized, leaving us to wonder if we've truly progressed or just found new ways to hide our marvels. 5 critical moments changed everything we thought we knew about the Lycurgus Cup, each discovery peeling back another layer of its impossible secret. The countdown begins in 1850 when the cup first emerged from the shadows of history. Unearthed somewhere in the Mediterranean, likely a Roman tomb or aristocrat's villa, its origins were already a mystery by the time it reached European collectors. Back then, no one understood why this ancient goblet seemed to flicker between colors. It was dismissed as a curious oddity, a trick of the light rather than a technological marvel. For decades, it passed through private hands, its true significance locked away behind glass and ignorance. The next breakthrough came in 1958, when the British Museum acquired the cup and subjected it to rigorous scientific scrutiny. Curators noticed something peculiar. The color shift wasn't just surface level. Light behaved differently passing through the glass compared to bouncing off it, suggesting a property embedded deep within the material. Initial chemical tests revealed traces of precious metals, but the technology to analyze further didn't yet exist. The cup became a puzzle without a key, sitting in quiet defiance of every assumption about ancient craftsmanship. Then, in 1990, electron microscopes finally cracked the code. Researchers zoomed in on the glass at magnifications unimaginable to its creators, and there they were. Billions of gold and silver particles, each smaller than a wavelength of light, suspended like stars in a midnight sky. This wasn't contamination or accident. The nanoparticles were too uniform, too perfectly sized. The implications sent shockwaves through the scientific community. How could artisans without lenses, let alone atom-level imaging, have engineered such precision? By 2005, advanced spectroscopy revealed even more stunning details. The ratio of gold to silver wasn't random, it was calibrated, with about 1 part metal to 1,000 parts glass. Too much gold and the red would overwhelm the green, too much silver and the effect would vanish entirely. The artisans hadn't just stumbled upon nanotechnology, they'd refined it through trial and error, like master chefs tweaking a recipe until it sings. The final revelation came in 2015 when physicists modeled the cup's behavior using quantum mechanics. The nanoparticles' interaction with light, a phenomenon called surface plasmon resonance, matched cutting-edge research in photonics. The same principles now used in everything from cancer treatments to solar panels. The Lycurgus Cup wasn't just ancient art. It was a 2,000-year-old preview of technologies we're only now beginning to harness. Each discovery in this timeline doesn't just deepen the mystery, it rewrites it, proving that some secrets don't fade with time. They wait, patient and glittering, for the future to catch up. Visitors to the British Museum often walk right past treasures like the Rosetta Stone or the Elgin marbles when they hear the whispers. "Over here, you have to see this," someone murmurs near case 52, where a small glass cup rests under carefully calibrated lights. At first glance, it seems unremarkable, just an ancient greenish vessel with worn carvings. Then a museum attendant steps forward with a flashlight, and the room collectively gasps as the beam passes through the glass, igniting it into a glowing, translucent red. Grown adults clutch strangers' arms. Children demand to know if it's magic. Scientists, despite knowing the physics behind it, still lean in closer, as if half expecting the cup to reveal another secret. One curator recalls a physicist who visited weekly, notebook in hand, sketching the cup from every angle. He kept muttering about plasmon resonance, she says, but by his third visit, he was just sitting there staring. Finally, he told me, "I've modeled this effect in labs for years. Seeing it crafted by hand 2,000 years ago, it's humbling. Others react more viscerally." A 6-year-old once declared it a superhero cup after watching the colors shift, while a retired glassblower burst into tears, overwhelmed by the precision of work he couldn't replicate with modern tools. The most striking reactions come from those who stumble upon it unaware. A group of Italian teenagers, dragged to the museum by their school, had been scrolling through phones until the cup transformed before their eyes. They thought it was a tech installation at first. A guard laughs. When we told them it was Roman, they started arguing about aliens. Meanwhile, elderly visitors often grow quiet, one even whispering, "This is why I never believed we were the first to discover everything." What unites these reactions is the cup's ability to collapse time. For a moment, the 4th century artisan who crafted it and the 21st century tourist pressing their nose to the glass field connected across millennia, both equally stunned by the way light bends to this object's will. The British Museum's guestbook bears witness, filled with entries in dozens of languages, all saying some version of the same thing: how and more. The Lycurgus Cup doesn't just belong to antiquity, it belongs to anyone who's ever marveled at the impossible made real. Buried beneath layers of dirt and time, the Lycurgus Cup should have crumbled centuries ago. Ancient glass, especially something as delicate as this, rarely survives the ravages of earthquakes, looters, and chemical decay. Yet here it is, flawless enough to still dazzle us with its color-shifting magic. So how did this fragile marvel defy the odds? The answer might lie in the very earth that hid it. Most Roman glass fragments we find today come from trash heaps or collapsed buildings exposed to centuries of weathering. But the cup's pristine condition suggests it spent much of its life sheltered, perhaps sealed in a noble's tomb, where stable temperatures and minimal humidity slowed the degradation of its glass matrix. Picture a pitch-black chamber, untouched by light or air, the cup resting beside bones and grave goods, waiting for the modern world to rediscover it. Then there's the nanoparticles themselves. Gold, unlike iron or copper, doesn't corrode. Those minuscule flecks of precious metal that give the cup its magic also acted as microscopic guardians, resisting the chemical reactions that would have turned ordinary glass cloudy or brittle over time. Silver, while more reactive, likely formed a protective oxide layer that stabilized rather than destroyed the structure. It's a twist of fate. The same innovation that made the cup extraordinary also became its best defense against time. Even the cup's design might have played a role. Unlike thin-walled vessels prone to shattering, its sturdy construction, thick enough to carve Lycurgus's torment in such detail, gave it structural resilience. But survival isn't just about materials, it's also about sheer luck. The cup could have been smashed by a falling roof beam, melted down for its gold content, or ground into pigment during the Middle Ages like so much ancient glass. That it avoided these fates suggests a rare journey may be passed down as a curiosity in some noble's collection, or tucked away in a monastery's treasury as a relic of miraculous properties. Every close call it sidestepped feels like a defiance of probability, as if the cup had a will to endure. The real miracle, though, isn't just that it survived, it's that we found it. For every Lycurgus cup pulled intact from the earth, countless masterpieces likely turned to dust unseen. This one slipped through the cracks of history, not because it was indestructible, but because it was cherished, hidden, and ultimately forgotten just long enough to escape the chaos of the centuries. Its survival isn't a fluke, it's a series of near-impossible accidents, each one a silent collaboration between human hands and the patience of the dirt that kept it safe. The Lycurgus Cup stands as a breathtaking collision of art, myth, and science, a relic where craftsmanship and physics intertwine so tightly they become indistinguishable. Its carved vines tell a story of divine retribution, its shifting colors whisper of atomic precision, and its very existence forces us to rewrite what we thought possible in the ancient world. This isn't just a cup, it's a time capsule, one that challenges our assumptions about progress and the linear march of knowledge. The Romans who shaped it didn't merely create an object, they encoded their understanding of transformation, both literal and metaphorical, into glass, trapping light itself in a dance with metal particles they could never even see. Think about the layers at play here. On the surface, there's the myth of Lycurgus, a warning etched in glass about the dangers of defying the gods. Then there's the artistry, the painstaking chiseling of figures so lifelike they seem to writhe when wine fills the vessel. And beneath it all, hidden in plain sight, is the science, nanoparticles engineered with a precision that borders on clairvoyance. Most artifacts from antiquity excel in one of these realms: a statue's beauty, a tool's ingenuity, a text's wisdom. The Lycurgus Cup does all three at once, weaving them into a single, shimmering paradox. But here's what lingers long after the initial awe fades. If the Romans could master nanotechnology without the tools to observe it, what else might they, or other ancient civilizations, have known? The cup is a solitary survivor, but history is rarely so tidy. Could there be other artifacts equally advanced, still buried in unexcavated tombs or mislabeled in museum vaults? The ancient world was full of innovations we've only begun to rediscover: Roman concrete that heals itself, Greek fire that burned on water, Damascus steel forged with nanostructures rivaling modern alloys. The Lycurgus Cup isn't an anomaly, it's a clue, a single thread in a tapestry of lost knowledge we're only starting to unravel. So where does this leave us? Standing before the cup in the British Museum, watching its colors shift under the lights, it's hard not to feel a humbling connection across time. The artisans who crafted this marvel didn't just leave behind a drinking vessel, they left a challenge. A dare to look closer, to question deeper, to wonder what other secrets might still lie hidden, waiting for the right light, the right angle to reveal themselves. Maybe the next breakthrough isn't in a lab or a futuristic material, but in the past, whispering from behind glass cases we've yet to examine with fresh eyes. The real question isn't how the Romans made the Lycurgus Cup. It's this: if they could do this, what else don't we?